Hi, welcome back to part 2 of our 4.6 notes. In this part, we're going to do proofs using the Isosceles triangle theorem that we talked about earlier in part 1, where if I have an isosceles triangle, then the base angles are congruent, or if I have congruent base angles, then the sides opposite those base angles are congruent. And here's a new extension to our proofs that we're going to do. Proving Cpctc. What does that mean? It means that if two triangles are congruent, then all pairs of corresponding parts are congruent. So if I've got a triangle there and I've got a congruent triangle, well, if these are congruent, then this angle should be congruent to its corresponding part. Or this angle should be congruent to its corresponding part. Or this side should be congruent to its corresponding part because they're congruent triangles. So here we're going to use our isosceles triangle theorem to prove that two segments are congruent. I want to prove that CE is congruent to CF. So how are we going to do that? We're going to have to prove that this triangle is congruent to this triangle. Maybe I should do that in a different color. I want to prove that these triangles are congruent because then my corresponding parts would be CE and CF. So how can I do that? Well, let's go back to our isosceles triangle theorem. Look at your big triangle here. You've got CD is congruent to CG. You have an isosceles triangle. So what base angles are going to be congruent? I'll give you a second to think about that as I make my proof structure. So these would be my givens. There's nothing to define here, no vocabulary words in my given statements. So now let's go back to that original question. Where are my base angles that are congruent? Well, they're here and here because they're opposite those congruent sides. So I can say CDG is congruent to angle CGD because this is an isosceles triangle. And after every step you do in one of these proofs, you should always ask yourself, do I have enough for congruence now? So let's check. Here's one triangle. Here's the second triangle. Do I have enough for congruence there? Looks like I've got side, angle, side here, and I have side, angle, side here. So it looks like I do have enough for congruence. I can say that my triangles, CDE, are going to be congruent. So CDE is congruent to CGF by, we said side, angle, side. And our goal will forever be to prove that my triangles are congruent first. But now that I have my triangles are congruent, now I can say something a little bit more. So your goal will forever be to prove triangles are congruent. in chapter 4, no matter what, always prove the triangles are congruent. Once you have congruent triangles, then I can claim any pair of corresponding parts would be congruent. And CE is definitely congruent, definitely corresponding to CF. Those are corresponding parts. So if they're corresponding, then I can say that they are congruent because the corresponding parts of congruent triangles are always congruent. All right, let's try another one. I want us to prove first that these triangles are congruent. So I want you to prove that the triangles are congruent. I'll give you a couple minutes to try this one on your own. Then you can always unpause and check your work. So first we do our givens. And again, if you're not done, just pause the video, finish it, and then unpause to check your work. Start with your givens. Then I typically encourage you to look through the given statements for any vocabulary words. Here I have a midpoint. So V is the midpoint of RT. Now if V is the midpoint, what does a midpoint do? It's in the middle. A midpoint is going to bisect a segment. So what are the two congruent parts of RT now that you have V right in the center? Should be RV and VT, or RV and TV. So RV should be congruent to TV by that definition of midpoint. If it's in the middle, then I know that those two segments are congruent. Let me mark that in. So I did my definitions, I did my givens. Let me look for some vertical angles or shared sides. And I see that VS is here, a shared side. So I can say that VS or SV is congruent to SV by that reflexive property. And I should check, do I have enough for congruence yet? And I do. So here, I've got enough. I can say that triangle RSV is congruent to triangle TSV by side, side, side. And then once you've got that those are congruent, you can prove any corresponding angles are congruent. Here I just said RSV was congruent to TSV, those angles, and they would be congruent because they're corresponding parts. You could also prove that SRV is congruent to STV, or you could even say that angle RVS is congruent to TVS. You could say that those two angles are congruent if you're trying to prove that this is a right triangle VST or a right triangle VSR. But you can prove any of those angles are congruent because they were corresponding, and corresponding parts of congruent triangles are congruent. All right, we got two more proofs to try. I'd like you to try these two on your own. And then I want you to prove here that, let's say, angle JKL is congruent to angle PML. And again, pause the video, finish the proof, and then unpause to check your work. In this one, you really didn't need anything. You could have used your definition of bisector to say that KL was congruent to LM. That could have been your second step. So you could use definition of bisector to say that KL was congruent to LM. Or you could use vertical angles to say that this angle is congruent to that angle. You could say KLJ is congruent to angle MLP because they're vertical angles. And then you could use side angle side. You could use angle side angle. You could use angle angle side to prove congruence, but you really didn't need to do any of that. None of this was necessary because originally you were given side angle side, side angle side. So you didn't even need to do any of this work. You should always check if you have congruence first, and then check after every single step. But I'm going to leave that stuff in there just because it's interesting. And I'm going to say that triangle JLK is congruent to triangle PLM. And you could use side angle side, side side side, angle side angle, angle angle side. Doesn't matter. I'm going to use side angle side since it was the original given information. Why did I put triangle? They're congruent by side angle side. And then your last step should have been that angle JKL was congruent to angle PML by corresponding parts of congruent triangles are congruent. And our last proof here. I want to prove that angle LNM is congruent to angle LNP. Again, pause the video, finish the proof, unpause, check your work. And you should have started with givens, and then I would have done ln is congruent to ln by the reflexive property. And then you've got side, side, side. So then you can say your triangles are congruent by side, side, side. And then you can say that your angles L, N, M, and LNP are congruent because those corresponding parts there we go, corresponding parts of congruent triangles are congruent. So that's the 4.6 proofs, part 2. Let me know what questions you've got, and I will see you in class.